use the data to come up with some equations, and then we're going to use the equations to answer questions about the data. What's up? Okay, why are you here and not there? Oh, okay. All right, so the first one that we are all right, let me change this up. I learned a little bit from some mistakes that I made first period. If you guys would open up the calculator, like I said, you should have a screen that looks pretty much like this, okay? What we are going to do, I think this is the best way to do this. It's going to be a little bit tedious in the beginning, but if we do the work in front to start with, then it's going to make the rest of it easier, okay? We are going to use either a linear equation, a quadratic equation, or cubic equations for the data. So what we're going to do to start with is we're going to enter all of those so we have them all ready to go. So the first thing we're going to do is the linear equation. So we're going to go y1. So type y and then a 1, and then it should automatically make the 1 into a subscript for you. We've done this before. Then if you go to the keyboard menu, the squiggly line is on the bottom right, okay? So we're going y1 is approximately equal to, and then for the linear equation, I know you guys know mx plus b, but we're just going to go a x1 plus b, okay? And that's going to give us the linear equation. I don't know why that stuff is there. You might not have that stuff, or it might be different. That doesn't matter. We'll mess with that later, okay? So that's the linear equation that we've done before. We're also going to do a quadratic. So again, y1, and then go to the keyboard menu, hit the squiggly, and then this time we're going to go a x1 squared, because we're going to do the quadratic, plus bx1, got it, plus c. So that would give us the answer if it is a quadratic equation. And then this is the new one that we're going to add today. We're also going to do ones that are cubic. So that's super fun. So we're going to do y1, go to the keyboard, approximately equal to, you're terrible, a x1 cubed this time. Okay, so the way you do cubed is you hit this a to the b button. That's the general exponent button, and then you type in 3. And then after you type in the 3, you got to arrow over to the right to get out of the exponent. And then go plus cubed. What? Plus bx1 squared plus cx1 plus d. Okay? With that, you need to get back out of it. Okay? Arrow out. All right, so I know that was a little bit of work. But what we have now is we have a linear, we have quadratic, and we have cubic all ready for us to go, so we don't have to enter those in again. All right? Yep. What other one? Linear. Okay. All right. So let's tackle our first problem. So in the first problem, it says we're just going to start with. It says what polynomial function has a graph that passes through the 4 points 0, -3, 1, -1, 2, 5, and negative 1, negative 7. So what we're going to do is we're going to take these and turn them into an XY table. Okay? So our first point is 0, negative 3. Our next point is 1, negative 1. Then 2, 5, and negative 1, negative 7. Right? Abby? You should know those, yeah. So if you need to write them down to know them, then you could sure write them down. What's that? The last one was that guy right there. For cubic, because it's to the third power. Okay. That's quadratic, because it's to the linear. Okay, so what we're going to do now is I'm going to click on this box below that. I'm going to hit the plus sign up here, and I'm going to add a table. Okay? And then I'm going to use this to enter in the points. Okay, now before we do this, I don't know if this happened to you, Anna. This is an important thing. Don't screw this up. You see how this says x4 and y4? Yeah. All of the things that we just did were x1 and y1. So I need to change that x4 to x1, and I need to change that y4 to a y1. So if your table came up with something different than x1 and y1, make sure you change those, or none of the work that we did is going to be useful. I think it's a 4 because I started out in the 4th box. I've never done that before, so that's a learning. I learned something today. What? No. No. Okay, so let's enter the points now. So I'm going to put in the y's first. So 0, 1, 2, and negative 1. So 0, 1, 2, and negative 1. And then I'm going to enter in the y. And the y's were negative 3, negative 1, 5, and 7. Okay? So that's the table of values. All right. So Emma asked a great question, and it's really what this lesson is all about. She said, do we need to use all of those? And the answer is no. We're trying to find the one that is the best. Okay, Brianna? Was it negative 7? It is indeed negative 7. Thank you for correcting me. That would have been disaster. Okay? Yeah, you might have to zoom a little bit to see the dots. Here's what I have. Here's the 4 dots. Here are the 3 different graphs that go through. Okay? Now, the way that we're going to decide which one is the best is by comparing these R values right here. Okay? We've talked about that before. The R value tells you what percent accurate yours is. Okay? Linear, you can see, is pretty good. It's like 96%. Quadratic is a little bit better, 97%, but if you go down to the cubic one, you should notice that the R value is 1, which means 100%, okay? So in this case, this is going to be the best one, all right? So what we would do then to answer this question is I'm going to take the values that it gave me for A, B, C, and D, and I am going to use those to write out a cubic function, okay? This is the coefficients that go in front of the variables. So y equals 1x cubed minus 1x squared plus 2x minus 3, okay? So that's the answer, all right? Now, for those of you that are a little bit smarter than your average bear, you'll say, do I need to write the 1s there? Absolutely not. So you could just write y equals x cubed minus x squared plus 2x minus 3. I wrote the 1s here so you could see the connection to the numbers that the calculator gave us. Okay? So this is the answer, not A, B, C, and D. You have to write it out as a polynomial function. Okay? Yes. What? We did. We did this with linear ones, and we did this with quadratic, so the only thing that we're doing differently now is we're doing it with higher power ones. Thank you for saying that, because you would think from listening to like the other 85% of the class that like I just asked you guys to develop a rocket ship that will take us all to the moon. It's like, what are you talking about? No idea how to do any of this. I'm so... There you go. Thank you. Yes. So the first one's linear, the second one is quadratic, and the third one is cubic. No, the cubic is the only part that's new, but it's so closely related to the linear and the quadratic. Okay. Our next quiz is tomorrow. I'm serial. Yes. Crazy, right? All right. Yeah. I said we're having a quiz tomorrow. Yeah. What the front door? Okay, let's do another one. This time, shh. This time, shh. We're given some real world data, okay? And notice how clever they are about their display. The first milk bottle comes from 1955. Look at the 1955 milk bottle style, okay? Then 1980, we've modernized it a little bit. And it's also maybe bigger, and then 2005, okay, whatever. All right, so again, we're going to turn this into an XY table. So in 1955, people in Wisconsin made 16.5 billion pounds of milk. In 1980, I shouldn't say made it, they produced 22.4 billion pounds of milk. And in 2005, they produced 22.9 billion pounds of milk, okay? Now, when we're dealing with real-world data that comes in terms of years, we're going to change the way we enter the data just a little bit. I am going to, instead of entering 1955, I'm going to enter that as year 0, okay? It makes the numbers that you get for the equation way better, yeah. So then McKenna says, well, if 1955 is year 0, then 1980 must be year 25, okay? And that means 2005 would be year 50, all right? Now, honestly, you don't have to do that. If you entered it in with 1955, 1980, and 2005, in the end, you would get the same answer. I'm just giving you a little pro tip. It's a little bit easier if you change the numbers, okay? So now I'm going to go back to the table. I'm going to leave the 0 as 0. I'm going to change the 1 to 25. I'm going to change the 2 to 50. And then I'm going to delete the -1 altogether. Uh-huh. No, with Desmos. Yeah, with Desmos. Yeah, I'll have these in here and you can use it. Okay? Okay, then in 1955, the amount of milk produced in Wisconsin was 16.5 billion pounds. 22.4, thank you. I don't know, isn't that weird? I would have thought gallons, yeah. But maybe they just weigh the cows before they milk them and weigh them after. I don't know. What was it for 22.9? Thank you, David. Okay, and then I want to get rid of the last one. Okay? All right, so once again, I have to make a little bit of a choice. Which model do I think is the best? Okay? So if I look at the first one right here, this is about 80% accurate. If I look at the quadratic model, that's 100%, so that's good. And then if I look at the cubic, that's also 100%, so that's also good. So how do I choose between those two models? Okay, Abby? The coefficients come out to be weird, but if I zoom out and find the points, what it's saying is both of those graphs go through all three of those points exactly. Okay? I agree with what Sydney said. We should just use whichever one's easier. Which one is easier, the cubic or the quadratic? The quadratic, because it has fewer things, okay? And so that's exactly right. When there's a tie, you just go to the simpler model, okay? Yeah. Yeah, exactly right. Yeah. So you should be super happy because actually there's basically zero thought in this. It's all just data entry. Okay, yeah, the questions aren't very hard at all. You're just typing things into the calculator, which sadly, most of the people who actually do this for jobs, that's what they do. They just sit at a computer and enter the data, and then just the computer does all the work for them. Anyway, okay, oh, it does say what linear model. Yeah, so we broke the law there. Okay, yes. Yeah, I wanted to become a, what's that called, an actuary, so then I wouldn't have to deal with you guys anymore. So I wouldn't have to be like, Alexandria, will you get off your phone for crying out loud? Colby, will you pay attention like 2 things I say once all year? That kind of stuff. But no, I would miss you guys, really. It's a great job. I agree. Plus, you said to do it this way, and you're never right. Okay, so there is our equation. Yeah. We chose to use quadratic. And here's why. The quadratic one was 100% accurate. The cubic one was 100% accurate. Which one do we use? Sydney says let's use the easier one, okay? So the quadratic one is easier not only because it only has an A, B, and C, but also look at these numbers here, 0.0000603562. That's nutso. I don't want to deal with all that. This is much easier, okay? So I'm going to get rid of this one too, all right? And we're going to go with the quadratic. Yeah, right. So I rewrote this thing right here with the A and the B and the C in there instead. We're going to do one more. Right, for sure. Okay, so then this problem, they would also like you to use this to figure out how much milk was produced in Wisconsin in the year 2000, okay? The easiest way to do this, since we already have the graph, is to say, okay, what X value would 2000 go with if 1955 is 0? 45, nice job, Anna. So I'm going to go on the graph, and I'm going to go to 45. I'm going to click on that point, and I'm going to say 23.2 billion gallons. All right? So it looks like when X equals 45, Y equals 23.2. Okay? Yeah. Oh, okay. Yeah, that's fine. Anna? Put it in what? No, actually it doesn't matter. No. Brianna, an easy way to do this if you want an exact answer is if I also graph y equals 45. Oh, no, sorry. X equals 45. Then that will create an intersection point on the graph, and then you can click on it and it'll give you the thing exactly if you want. Okay. All right, let's do one more. This was a big learning moment for me when I did this with my first period class. This is actual real data about cheese consumption in the United States. Okay? So what this says is on all the different years, This is how many pounds of cheese the average American eats in a year, okay? And what I think is a little surprising is how much it has gone up. That in the 40s, you were only eating about 5 pounds of cheese per person a year. In 2001, that's all the way up to 30 pounds of cheese per person per year, okay? I like cheese too, okay? All right, so same thing as before. I am going to turn 1910 into 0, which means 1940 is 30. 65, 85, and then 91. Okay, so will you guys take a minute to enter that, change the table of values into that now? Okay, and then once again, we're just going to ask the same question. Which of those 3 models fits this data the best? And then whatever that comes up with, that is our answer. Yes. Right. You mean once? Okay, so strongly suggest you guys do as much of this as you can right now while you have access to the iPads. If you don't get this done, you can finish it at home on your phone or whatever. If you don't have technology at home that you can use and you don't get it done in class, you're welcome to come in the morning and use one of these bad boys, okay?